My name is Anthony Nathaniel, and today in our further mathematics class in Global Education Zone channel, we'll be talking about sets. Now, sets is a very important part of further mathematics and even mathematics. If you are in if you are in high school or secondary school, you probably have done some topics in sets, but regarding sets. So, but today we are going to delve into it full time. We are going to give a summary of what set is all about. Now, what is a set? A set is basically when you have a house, the people in that house is kind of like a set, and then you can observe set like a collection, like a group, like an enclosure, like a selection, like a sample. That's what a set is. A set is basically something that contains another thing, and that thing that contains another thing is called the set of that thing. Now, basically, if we say if we have a mathematical set, now something like this is a math set. Now this is a typical math set. This is a math set and calculator together. Now this math set, if we have this math set and then we have some things inside this math set, now this mathematical set has some items like the compass, your protractor, and so on and so forth. So now, though right now it's virtually empty, but yes, it's kind of virtually empty. Sorry about that. So now basically, and now this math set, everything that is inside this math set we call the elements of this math set. Now because it is part of what is inside this math set, mathematical set. Now what is not inside here will not be called an element. Only the things that are here that will be called an element. And then this specifically is called a set of mathematical instruments. So that is simply an analogy, a demonstration and illustration of how you can understand what a set is. So don't be bored about the bogus grammars or illustration or whatever. A set is simply a collection of things, and those things might have a relationship between them or not. Now, the things in the mathematical set, like I demonstrated earlier, the things in the mathematical set, some of them are related, some of them are not related. Now, those are related, they have their properties. Those are not related, they have their properties. Yes, so I can have a set of people, I can have a set of instruments, I can have a set of something, but the most important thing is that set of something, those elements are contained in that set. That is what a set is. Just a collection of elements which can be related or might not be related. So you can define set in different ways. You can define set basically as the general term, as the general nature of your properties. For example, now it's something like a mathematical set now is defined in terms of the general nature of its properties. Now what is inside the mathematical set? They are used for calculating, they are used for mathematics and all the rest, and geometry. So now you can call this a mathematical set. You can even call it a geometry set. You can name your set anything, but now you can name it in terms of the general property of the instrument, because those things that they are generally used for calculating mathematics and geometry. You understand? So basically, that is how we can name a set. We can also name a set based on its elements, based on the name of elements. You can list out the elements of a set. Now, if we have a set R of real numbers, you can call this set the set of 0, 1, 2, 3, 4, and so on and so forth. Now, anytime you see ellipses, let me correct this one. Anytime you see ellipses after the members of a set, it means that set is an infinite set. Now that leads me on to finite and infinite set. Now a finite set is a set that contains a limited set of elements. Now, for example, if in this mathematical set, for example, is a finite set because I know the amount of things that are in this mathematical set. Now, but in this set of real numbers, now this set of real numbers 0, 1, 2, 3, 4, 5, and so on and so forth, it will keep counting. Those elements are called infinite because you can never get to the end. For example, if you like mathematics and you like listen to a mathematics class, you would have understood that many of our sets, they are infinite, because like for the set of real numbers, it goes on from 0 to 1 to 3 to 4. The set of positive numbers goes from 1 to 3 to 4, 5 to 6 to 7, 8. Set of natural numbers also goes from 1 to 3, 4, 5 to 7, 8. So now those sets, when you keep counting, you get to 100. If you keep counting, you get to millions. If you keep counting, you get to billions, to trillions, to zillions, and so on and so forth. So they never end. Those members of a set, and that particular set which contains those members, is known as an infinite set. But if you can list all the elements of a set, it's called a finite set. You understand? So finite is finite, and then infinite is finite. So now we'll talk about different other types of sets. Next, we'll have to talk about a subset and a superset. Now imagine I have a set of if I have a set S. Now we often denote our sets by numbers, by letters. We can say set S, set A, set B. We can also say the set of mathematical instruments. So it depends. We can give the set any name. But what matters is the elements that are in that set. You understand? So basically, now if we have a set S of where the set S has letters A, B, C, D, and E. Now, if we take some of the elements of this set, A, B, C, D, and E, if we take part of them and then we use them to form another set, that new set that we have formed is known as a subset. Why is it a subset? If you take English classes, you will understand that anytime you have the sub, the prefix sub before a name of something, it means that thing is gotten from something else, or it's lesser than something else. So subset is basically another set that is lesser than that set, and that subset, all the elements of that subset are gotten from the set, the previous set, and that previous set is also known as a superset. Now if I have a set T now, set T, and that set T is A, B, C. Now I can call this set T the superset. And note that when you have a set, you always represent your set within curly brackets. So those curly brackets are used to represent your set. You understand? So now this set T is a set that contains the elements from S. So just like if we have done an extrapolation, we've done an extraction. So we've extracted some of the elements of S and then we've used them to form T. So it's just like the child, it's just like the progeny, it's just like the subsequence of, or the consequence of a previous set. And that new set is known as a subset, but the initial set is called a superset. So then we have other types of sets. We have universal sets, and a universal set is a set that contains all other sets. So a universal set contains everything. Then we have empty set. Empty set contains nothing. We have unit set. Unit set contains only one element. We have the cardinality of a set. Now, basically, let me explain what cardinality of a set is. Cardinality of a set is basically the number of elements in a set. Now, if you have the set S has elements A, B, C, D, E. Now, the elements of a set are always separated by commas. Now, those elements of a set elements A, B, C, D, E. Those elements, they are called the elements of a set, right? And then the number of elements is called the cardinality of a set. Now, if I count the elements A, 1, 2, 3, 4, 5, A, B, C, D, that's 5 elements. Now, the cardinality of set S will be known as 5. But this set T, that's A, B, C. Remember that the elements of a set are always separated by commas. Now, if you have A, B, C, now those are 3 elements, right? And the cardinality of a set becomes 3. So in summary, this cardinality of a set is basically the number of elements in a set. So we also have other terminologies associated with sets. We have different types of terminologies. We have cardinality of a set, we have so on and so forth. But as time goes on, you will encounter them in calculations in sets. Now let's move on to definition of some things in sets. Now basically we want to draw a sample of sets. Now I mentioned earlier some types of sets. I talked about universal sets, subsets, and superset. Let's make a representation now. Let me give an example. Now this example I'll give here is this. In a dancing competition, each competitor could dance to at least one brand of music played. 2 brands of music, Fuji music and jazz music, were played that day. 10 of the competitors could dance to Fuji music, while 14 of the competitors could dance to jazz music. If 4 of the competitors could dance to both brands of music, find the number of competitors that could dance to Fuji but not jazz, and so on and so forth. Now, basically, what this means is that in this question, it says that 10 could dance to Fuji, 14 could dance to jazz, but then 4 could dance to both jazz and Fuji. So now let's represent the universal set. The universal set will be the total number of dancers. Let's call it a rectangle. So this will be the universal set here. This will be the universal set. We call it set U. And then this set U has a subset. Now any set that is inside another set is called the subset. Now the subset of set U is the set of people who can dance to Fuji music. Let's call it, they are 10, right? So let's call this set subset F for those that can dance to Fuji music. Then we now have another one for jazz. So 10 of them could dance to Fuji, while the 14 could dance to jazz. Now you can represent your set. You can place the circles in contact with each other so that there will be a space, a region within them. Now the only reason why you can do that is if there's a union of those sets. Now a union of that set is a subset, is another smaller set that contains both the elements of the first 2 sets. So when you have a union of the set, you can now cross the circles can now intersect like this. So that region where they intersect is called the union of sets. And then this set of jars, let's call it J. So now this set intersect, they have a union, and then those that in the first circle we have a total of 10 people for Fuji. So we'll say the number of sets n. Now the cardinality of sets is represented by n open bracket the name of the set nf. So if I want to represent the cardinality of set, I will say n open bracket f. If f is the name of the set, then I'll now close my bracket. Nf is equal to what? They said 10, right? Then we have the cardinality of they said 14 could dance to jazz. So that means 14 is in jazz, the set of jazz, right? So that means the cardinality of jazz set will be 14. So nj will represent jazz set by j. Nj is equal to 14. Now they not added again that 4 of the competitors could dance to both brands of music. Now that means this, what do we call this space? What do we call it? Now in an intersection of sets, we have what is called n, right? That's cardinality. Now that intersection is represented by the letter n. So it's like it's like a U that's facing downwards. So let's say the n of the cardinality of the set. The intersection of F Fuji and jazz set is F intersection J. So that's the symbol for intersection. When you have the two sets coming together to have a common element, so that intersection is called F intersection J, and that intersection, the symbol for that intersection is like an inverted U. So now that cardinality of that new set is 4. So that means we can easily say that in this intersection there are 4 people. So now even in this whole circle there are 10 for Fuji. 10 people study Fuji, and then out of that 10, 4 can dance to Fuji and jazz. So how many people can dance to only Fuji? So that will be the subtraction of 4 from 10 to get the people that can only dance to Fuji. That will be 6. Then again we'll subtract 4 from 14 to get the people that can dance to only jazz. That's 10. So we have successfully extrapolated some information from our question. So let's move on now. This question said find the number of competitors that could dance to Fuji but not to jazz. Now what this means is that the competitors that could dance to Fuji only, and that is this circle. That is the part of the Fuji circle or the Fuji set that does not intersect with the jazz. So and that we have 6 inside. So that is number 6. So the number of people that can dance to Fuji only is 6. Then number 2, they said the number of competitors that could dance to jazz but not Fuji. So that is jazz but not Fuji. That will be the part of jazz that does not intersect with the Fuji set or the Fuji circle, and that is 10. So only 10 people could dance to jazz but not to Fuji. So I must say that those people, they like dancing a lot. Those people that dance to both. So then we have the last question as the total number of people involved in the competition. So now the formula for finding that is you add the people that dance to Fuji only, the add people that dance to jazz only, then now add them to the people that dance to both Fuji and jazz. That's 6 plus 4 plus 10. That's 20. So the total number, then we can also denote that as the number of the universal set, because anytime you hear the word total is like the universal set. So let's say the n cardinality of the universal set is like a U, represented by the U, is equal to 6 plus 10 plus 4, that's 20. That means 20 people could dance, 20 dancers in total. So this is an example of the type of question you'll be seeing in your WAEC, your NECO, or your JAM. So this specific type of question involves 2 subsets of universal set. So we have other questions involving 3 subsets of universal set. But before we go into that, let's talk about the general representation of sets. Now I will draw a typical set. I will draw a 2 set first. Now this rectangle, I could just keep using this one. Now this rectangle is the universal set, and then this first set we have the first set, we have the second set, right? Now the first set is the set that contains only Fuji. The first set is the set of Fuji, then the second set is the set of jazz, right? Now this Fuji set, there's a part of it that intersects with the jazz, and that intersection is at the middle. So and that intersection is denoted by F intersection J. So when you put an inverted U, F, it looks like an N, but it's not an N, it's like an inverted U. F, J, F, we'll say F, they will not put the sign like this, they will not put the J. So that is the intersection of the set, that's the middle set. Then we also have the set of F only. So and before that, let me talk about complement. A complement of a set is another set that contains the elements that are not in the first set. So now a complement of a set is like the opposite of a set. Now if you talk about the complement of a set, if you say the complement of me now is a person that we hate what I like and like what I hate. So and that is kind of like my antithesis. and I don't like this kind of thing. No. So basically, but in mathematics does not care about antithesis or opposition. So mathematics, for every set there is always a complement of a set. So now the complement of a set is the set that is outside the set you are considering. Now the complement of J is the set that is outside J, and that you note this complement of a set by a small stroke on top of the set. Now this set of F only, Fuji only, will become the set of Fuji and the complement of jazz. So that means that will be is noted by F intersection J complement. So that is for Fuji only. And then if you are deductive enough, you will understand that for jazz only will be jazz intersection Fuji complement, because that involves jazz only. And it whenever you talk about complement, the set that has the complement will not be included. So that's jazz intersection Fuji complement. So that is an example of the type of things you will be dealing with in set. And this is just a simple overview of set. And before I go, I have to talk about the disjoint set and power set. Now disjoint sets are basically sets that do not have anything in common. Now but essentially, let's talk about union of sets. We'll talk about union of sets. We'll talk about intersection of sets. Now a union of a set is basically the total element in those sets. Now the union of a set is the consideration of the universal set. When you talk about the union of sets, the set, like when you have two sets now, set A and set B. Now the union of this set B is the combination of when you add the elements of set A and then you add it to the elements of set B, you form a new set known as the set of the union. So that union set consists of the two. So if set A for example, if set A consists of letters A and B, and then set B consists of letter X and Y, so the union of this set will be A, B, X, Y. So we just combine two together. But then when you talk about intersection is the selection of those elements that are contained in only the first two. Now for example, in our set before, that we talk about A and B and X and Y. Now A and B, if there's anything that is in set A and that's also in set B, we'll consider that as an intersection. But from the example I'm giving now, you can see that A and B, they are totally different from X and Y. So and when there's nothing common with two sets, it's called a disjoint set. So you can take that. That's very easy to understand. So then, and lastly, we'll also talk about power set. And the power set is the set of all possible subsets of a set. That is a lot of grammar, right? So in simple terms, a power set is basically when you separate the element of a set and you combine it in different manner. That's the power set. So and the power set, the formula for a power set is basically 2 raised to power the number of elements in the set. So 2 raised to power. If we have 5 elements in the set, the power set of that set we have 2 raised to power n elements. So I hope most of you are perceptive enough for this explanation. But if not so, you can even come to the description of this video and ask for more explanation. But in summary, we've talked about set, the elements of a set, the complement set, universal set, subset, which is smaller than the superset. And when you have a superset, you can get a subset from a superset. We've also talked about disjoint of a set. We've talked about union of a set. We've talked about intersection of a set. We've talked about power set just now. So basically, I think this is a short summary of what set should be, and then should be able to gain from this. Thank you for watching.